The black hole is the most famous object in our universe. We measure them and accept them as a standard feature of the cosmos. But inside every single one of those objects lies a devastating mathematical failure. At the very center is the singularity, a point where matter is crushed into infinite density. When density becomes infinite, gravity becomes infinite. At that exact point, all of our established laws of physics simply break down and stop working. Physicists hate broken math. If the equations stop working, it means our accepted model contains an unresolved glitch. For decades, scientists have hunted for a workaround, an alternative cosmic body that could exist in that exact same space without breaking the math. The requirements for this theoretical replacement are strict. It has to warp space and trap matter identically to a black hole, but it must do so without ever forming a singularity. The answer physicists came up with is called a gravistar. It is a cosmic imposter, acting as the black hole's identical twin. The gravistar is a specific mathematical model, a proposal built to account for these massive objects without the need for a singularity. This diagram shows a black hole on the left and a gravistar on the right. From the outside, they are completely indistinguishable. Both show the exact same light-bending distortion patterns around their edges. They both swallow surrounding gas and dust with the exact same gravitational force. But if we look closer, we see the first major structural difference. Instead of an intangible point-of-no-return event horizon, the gravistar has a hard physical boundary. Physicists call this the ultra-thin shell. This shell is constructed entirely out of incredibly dense, ordinary matter, just packed together tightly, almost right up to the breaking point. Packing ordinary matter this tightly creates a serious mechanical problem. It generates an overwhelming amount of inward gravitational pull. Under normal circumstances, that shell should instantly collapse in on itself under its own immense weight. So for this shell to hold its shape without caving in, there has to be an impossibly strong internal force fighting back against the gravity. This cross-section of the gravistar shows exactly what is holding it up. Instead of a hollow vacuum, it has an energy-filled core. This core is comprised entirely of dark energy pushing outward against the inner wall. The outward pressure of that dark energy core perfectly neutralizes the crushing inward gravitational force of the shell. Because these forces balance each other exactly, the structure holds. This equilibrium removes the need for a singularity, offering a model that functions where the standard black hole math traditionally fails. When we zoom out to the scale of the observable universe, astronomers have spent decades mapping millions of black holes. But there is a massive observational problem. Because their external gravitational signatures are completely identical, our current telescopes cannot actually tell the difference between a black hole and a gravistar. That means every black hole humanity has ever observed might actually be a gravistar in disguise. Our structural map of the cosmos could be built on a vast case of mistaken identity. If true, this theory replaces the reality-breaking pits that we thought punctured our galaxies. Instead, we find a universe populated by elegant, tightly packed spheres of pure, balanced energy. The gravistar suggests that even our most established scientific facts are often just one mathematical revelation away from being rewritten.